Okay. We don't need to start right now yet. I'm not recording it yet. It's paused. Okay, well, we'll start. I'll go ahead and start. Hello, everyone. I'm Susan Nash. Happy to welcome you to New Revenue and Diversification Strategies workshops. And we're on week 14. And this week we are focusing on drones and robotics. And just to remind everyone, the goal of our series is to help people get new ideas during a time of pandemic, rapid change, of all types of basically sea changes, and to come up with new strategies, to be exposed to what other people are doing, to learn about opportunities, not just about the technology, but also how to get funding, how to get support. So tonight is no different. We have a great group today. And before we start, I'd like to welcome and thank our sponsor, Unique Ventures, and they're one of the people that are helping with acceleration and of new technologies. So our guests today are Sudhir Pai of Houston Technology Collaboration Center. So he's on the side of helping people get technology, get started, and focusing on new opportunities, getting guidance. We have Jamey Jacob, who's Oklahoma State University, and he's head of the drones and basically the robotics program, the air robotics and drones, and we're really excited to have him. And also we have Robert Dahlstrom of Apellix, who is doing robotics and robotic systems that are used for coding, cleaning, and measuring. We also have Munira Raji. Unfortunately, she's not able to be with us today because her little daughter, who's 3 years old, is sick and in the hospital. So our hearts go out to Munira, and we wish her well. So at this point, I'd like to also welcome Dr. Larry Davis, who's at the Texas A&M University, and I'd like to have him speak a little bit about his specialty, which is strategic planning.
I've talked about this every week. Strategic planning is an integral part of a business, and especially during the times where there are struggles because of such things as pandemics and coronaviruses, and that process will help some folks to survive. I'm excited about tonight's presentation. I mean, the terms robotics and drones strike a particular interest to me, and I'm looking forward to the presentations tonight to see what the presenters have to offer.
Well, that's great. So wonderful. Well, I'd like to start with Sudhir Pai. Would you like to share your screen and start your presentation? I think you're muted, Sudhir.
Yeah, sure. It asked a question. Now let's see if everything is fine.
Perfect.
Okay. Okay. Can you see everything there, Susan?
Yes, I see all of your slides. So all good.
Very good. Okay. Let me click a second and then, yeah. And,
it never fails. It goes great in dress rehearsal and then the gremlins.
Yeah, if for any reason things freeze up, please let me know. Of course.
Okay, so we need to hit start slideshow so that we can see the big size.
Okay, bear with me. Okay, all clear?
Yes, perfect.
Okay, so good afternoon, good evening, based on where you are. I know quite a few people are, I think, on this side of the pond, but a few people might be on the other side. So again, welcome to this event. Firstly, I want to thank AAPG and Tulsa Geological Society. Boy, Susan, it's week 14. Time really flies, right? As we have gone week through week on these events. And special thanks to you, Susan and Larry, for the outstanding leadership you have shown, putting these kind of sessions together. Wednesdays, 7 to 8:30 is just perfect. I think evening times and the diversity of the kind of talks which are put together, the speakers who are put together, etc., is absolutely outstanding. So thank you.
Oh, thank you.
Like Susan said, my name is Sudhir Pai. I'm right now the chair of the board of directors for the Technology Collaboration Center. For most of my career, I worked for Schlumberger, world's largest oil and gas service company. I'm one of those classical Schlumberger persons straight out of universities. So I did electrical engineering from University of Bombay. Joined Schlumberger and just grew with the organization. So 9 different countries, 26 different positions, 3 times to the US, every single time to United States, every time in 3 very diverse positions. And today we call Houston home, and we live here. Technology Collaboration Center that I joined in April of last year is an organization that is Houston based, but is we continue to branch to other places as well. That's our motto. But predominantly looking at the 3 main industries of Houston. We call ourselves the space capital of the world. And you've seen a lot happening in the last few months with the Dragon going up to International Space Station, and both of the astronauts spending 2 months. It was exciting. It's one of the first times in long time that a spacecraft left from US soil, docked on the US side of the International Space Station, undocked very successfully, came through the atmospheric zone and back landed in US soil off the coast of in the Gulf of Mexico. So exciting times. So that's the space side. Houston is also the medical capital of the world. Not too many people know that there are more doctors in 1 square mile, called the Texas Medical Center. A lot happening in there in terms of technology and research, etc., particularly with some of the heavyweights like MD Anderson, Memorial Hermann Methodist, all being located in there. And of course, the energy capital and soon to be the energy transition capital of the world, with a lot of organizations related to wind, solar, etc., starting shop here. Recently, you must have heard of the announcement of Greentown Labs moving here. Yeah. So today's talk, pivoting during the pandemic, robotics, history, developments, and new directions is what I will be focusing on. And this particular subject is extremely close to my heart because, amongst other things, one of the last things I did at Schlumberger was managed a joint venture between Schlumberger and a small California-based outfit. At that time, it was small. It started with 42 people in 2012, called Liquid Robotics. We formed a joint venture called Liquid Robotics Oil and Gas, which lasted for 4 years before Liquid Robotics Inc. was bought by Boeing. So some of the talk that I will do will talk about some of the projects that we did at that time. A couple of disclaimers. Any opinions that I give during today's talk are my personal opinions and not necessarily of anybody else or any other organization. And almost everything that I'm presenting today to the benefit of the audience is available publicly. So you should be able to find, but if you have difficulty finding where to go, my email is up there, sudhir@autoenergy.com. Feel free to contact me and I'll be happy to share that, yeah? Okay, so a quick slide about what the mission of the Technology Collaboration Center is. It's to be the premier organization to solve the most significant technical challenges with the greatest societal impact, a little bit like what Susan had mentioned in the lovely introduction she gave at the beginning, to partner across industries. And I had mentioned 3 industries, but there are others which are coming in, like manufacturing, like nutrition, and one of the largest, for example, one of the largest ports in the world is Port of Houston right here. So slowly you are finding that there are a lot of technologies which are common between these, and there is a very famous saying that I try and often mention, which is the solution to your problem might be in the toolbox of your neighbor. And in this case, it's neighboring industries. So it's interesting how over the last certainly 14, 15 months that I have been involved with this center, that you find that at the end of the day, you just need to take a step back, broaden your horizons, and suddenly you find lots of opportunity around. And at the end of the day, this is a new word which has been coined by the team here, which is collaborativity, which is the ability for innovation to be blending across the creativity and the collaboration across diverse industries. Yeah, it's a member-driven organization, so we have both large organization, medium organization, small organizations, startups, and individual members as part of the center. Yeah. With that come, obviously, one of the things we wanted to do was put up strategic teams. So make it strategic as well as tactical. So here are the key themes for 2020: imaging, wearable technology, sustainability, carbon footprint, water conservation, platform of the future, augmented reality, virtual reality, robotics, and automation are some of the themes that are coming up through 2020 and beyond, each one being led by one of the organizations with a board representative on it. One of the things I found out, it's all about leadership and commitment. Unless you have some organization taking ownership of it, often these things fall on the wayside and don't get the importance that they need. Some of the other things are tactical. For example, we get requests for methane monitoring and things like that. So we do these kind of services through what is called the concierge service. Again, feel free to go on the website, techcollaboration.center, and you'll find more information. I'll quickly zoom into now the main point of today's discussion. A lot of the rest of my talk is going to focus more on robotics. I have 2 lovely colleagues who are going to follow my talk. Jamey Jacob and Bob, and I know their talks are focusing more on robotics and drone, aerial robotics and drones. So I won't steal their thunder. I'll focus more on the other parts of robotics. And here is something interesting to talk about today's topic, which is history, where we are and where we want to be. And I looked up, and it's interesting, in a Forbes communication in July, they've laid it out extremely beautifully, which also made my life a little bit easy because I could reference to some of them. So since the term robot was coined around 1920s, so it has been there for centuries, depending upon how you define the word robot and how you define the word robotics and how you define the word automation. But the real big thing was seen in 1920 when robots started to become an important part of our lives. And it started with the requirement of the physical human labor, currently looking to robots to help or to fully replace humans with many tasks. So that used to be the focus. That's what it started, that there are a lot of things which are going on. How can I be away yet get the job done with robots doing it? And herein lies one of the domestic examples, like the iRobot vacuum cleaner, which you can program, you can leave it in the house, you can go away, and by the time you are back, for most of the reasons, it does all the work. And smart enough that when the battery goes out, it goes back and goes back to the charging station and lines up. And provided you have the right kind of internet service on the iPhone, you can have the app, you can monitor it remotely and tell it to do the next task. So, you know, a classic way that you can see that happening. Machines that can do the work of people without having the failings of people is where it started to gain very strong traction in the last, let's say, 20 years or so. But more and more these days, the term robot is used, particularly now, is used to describe any form of software or hardware-based automation, whether intelligent or not, that can perform a task that can otherwise require human labor and brain power. So very clear on that. And obviously there are lots of examples of this. Yeah. So as we pivot into new way of working, and what other time for this particular talk is and it's very apt. That's why when Susan reached out to me, I absolutely jumped onto this topic, because not only is this topic interesting to me, it's also the fact that in the current pandemic, in this new way of working, not only this new way of working, this to some extent semi-permanent way of working. When we came into this, we thought it was going to be weeks, months. Now, the more you go into it, it looks like it won't be surprised if this kind of thing continues this time next year or beyond, based on the success of the vaccines which are coming out, the antibody tests, et cetera, which prompted me to put up kind of this slide. So new directions. Physical robots are highly desired in many industries, especially to perform tasks often referred to as the 4 Ds, which is if it is dirty, if it is dangerous, if it is dear or expensive, so cost effectiveness is important, or if it is dull or demeaning, not to take any human's jobs away, but move the level of the need of a human being from doing the mundane kind of the work and diversify human talent and human requirement to places where they are really needed, and let some of the things that they treat as boring, where there is a lot of turnaround of human people, etc., changing. Yeah. Identifying opportunities where robotics are important. I mean, you can see that in terms of where it can be used, operational efficiencies, benefits and ROI, and help decrease costs, improve safety, and overall enhancement of the operations. I'll take a quick pause here. Susan, I'm looking at my watch. I know I have a shorter time, but understanding that we have one presentation short, do you think we should use up maybe 5 minutes of her time between the three of us?
If you want to. Okay,
very good. So I don't need to kind of rush through, but I'll be mindful of making sure that I don't exceed my times. Yeah.
I'll let you know if you get in trouble.
Sure. Yeah. So to move from mere automation to robotics and machines, essentially 3 steps are needed for that to be achieved. More responsiveness, more collaboration between various entities which are happening. Even today, a big focus is still, here is a task to be done, and you look at just that task and have the robots just doing that bit. So this is where I think the industry is slowly starting to move to be more collaborative, between human and robots, and between various robots. And the last one, which is I think is the most important thing, which is be part of the bigger picture. That is, they really need to be part of a bigger system, larger system. This is where you will start to see a lot of these coming into what is called the smart city concept. And Houston is one of the places, I think, which is being looked at as a pilot study for smart city concepts, wherein you look at the behavior of human beings, particular traffic lights, etc., and try and see what do they do in the presence and absence of the red, orange, and the green lights, and based on their behavior, traffic can move in. So with that kind of background, this is a slide which I really like to give kind of what is an operator's vision. And I want to thank BP for this, because they shared this slide with me, and it's available on their website. You see the link down there of how they've divided vertically between how you can use it as a satellite, as drones, autonomous surface vehicles, ASV, underwater vehicles, AUV, and then deep water. And I've given one example here in each of those cases of an application that can be used with LEO being a greenhouse gas monitoring, aerial drones, ability to do inspection of the offshore wind towers for an offshore turbine, autonomous surface vehicle, lots of them you see up there on the slide there, autonomous underwater vehicles, and I see there is going to be a talk which is going to come following mine. So that's very interesting. We look forward to seeing that one and the deep water one, which is IMR, which is inspection, maintenance, and repair. Platform of the future is one of the themes that we are taking within the organization. Going to have a lot of the lessons learned from being able to do unmanned systems with the rover, which is going on Mars, and the ability for it to go shallow into the surface strata, and trying to find out if at any time human existed, fully unmanned. And here is an opportunity to share that lesson with what we would call in the oil and gas industry as the rig of the future. So lots of things that can be learned between what you can do in terrestrial space versus what you can do on land and offshore with similar kind of challenges and similar kind of constraints. Yeah. And finally, like I had mentioned in this particular slide of the operator's vision just hold on, let me turn this thing off. Okay, so autonomous the surface vehicle, I talked about data acquisition, filling the gap. So here is an example I want to put up, and understanding that in one of the previous talks that I had done, the audience is not the same. I thought, let me repeat this slide in closing to show that the left slide is what you can acquire a seismic survey using boats through a streamer survey. But then just under, if you are doing all of this stuff around a rig or a unmanned platform, then you obviously do not have the data, and you see that up here on the left side, wherein there is no data in the center. But you can use robots, autonomous surface vehicles with seismic sensors attached to it, with the same source vessel, which is providing the sound signal to the sensors which are on the outside of the zone, wherein you cannot enter if it's a streamer vessel, by putting sensors in that zone. And then on the right side, you see it's almost like a carpet with a hole, and then you weave it with the same kind of a resolution and accuracy to get a nice fabric layout. So this is available in the Heart ENP magazine, and it was presented at OTC a couple of years ago. I'll stop here. It's been a pleasure presenting this and setting the stage for today's discussions. Again, happy to answer any questions which will come up when we have the Q&A session. So thank you.
Well, great. Thank you, Sudhir. And I just am really appreciative of that, because I know people may have questions about how to get started, and they can contact you and also basically find people to collaborate with, which is fantastic.
Absolutely, yeah. To take another couple of minutes, the way we try and conduct these kind of workshops, and last week we took the decision not to wait until everything becomes normal. So there will be announcements we are going to give out over the next 4 months to pretty much one a month to have sessions, and we divide these sessions between having people from large organizations come through. But having said that, in line with some of the talks that we've had today, there is a part we leave open, Susan, for startup companies to come in and give them a platform to present what they have to present and how they can contribute and provide value within the larger ecosystem. And very quickly they can reach out at a small price, and sometimes in fact at no price at all, blast out to out into the industry. And when I say out into this industry, within energy and outside of the energy industry, where they can kind of get together. Imaging, for example, is the same kind of techniques which are used between space medicine, between medicine and energy. So an imaging conference which we are going to put together, guess what? The two chairs are, one is myself, and my co-chair is the head of the imaging radiology technology at MD Anderson. It's going to be exciting to see how we collaborate on that day. I'm excited to look at that day.
Yeah, that's great. This is cross-pollination of industries is fantastic. So anyways, now our next speaker is Dr. Jamey Jacob. He's professor of mechanical and aerospace engineering at Oklahoma State University, and very involved in, from the very beginning, with unmanned aerial vehicles. And so really fantastic to have you here.
Oh, happy to be here. Yeah, thank you, Susan, and thank you, Sudhir, for that great introduction. I think you covered a really nice broad array of topics that sets the tone for everything that we're going to be talking about through the rest of this session for tonight. So let me just go ahead and jump in. So Sudhir gave a really nice overview of a lot of the things that we're facing within the industry. I'm going to take a pretty deep dive into one specific application of robotic systems, primarily drones, and really start to think about this from what we're going to see coming down very, very soon. For those of you that have been familiar with how quickly drones have been utilized in a variety of different industries, there's still a lot of limitations, both technical and regulatory, on how we can use those systems. But there are things that are being developed and tested right now that are going to change very broadly, not just within the oil and gas and energy sectors, but within all of society. And I'll talk about some of these things, but kind of at a very high level. So first off, when I talk about drones, what I really mean are small unmanned aircraft or small unmanned aircraft systems, those that are defined by the FAA to be less than 55 pounds. Now, interestingly, for those of you who are aviators or pilots, you know that there's a difference between, flying a fixed wing vehicle or, rotary wing vehicle, a helicopter. You have to get different training. You have to get different licenses from the FAA. As far as the FAA is concerned, they don't care. A drone is a drone is a drone. And so when we talk about these, we will include both fixed wing systems as well as rotary wing systems. So you can kind of picture in our head, what a drone may look like. It tends to look more like something on the right, but we mean a lot of different varieties. And one of the things I won't be talking about tonight is really the fusion of these two systems. There are advantages to both of these. Rotary wings are easier to use. They don't require runway, easy to take off from anywhere. Fixed wing systems have better payload and better endurance. They can fly farther and they can fly longer. So we're seeing a marriage of these two systems. So that way you really kind of have the best of both worlds if you can do things right. If you don't do things right, then you end up with the worst of both worlds. But as I mentioned earlier, what we've seen is really the promulgation of these unmanned aircraft really within just the last 5 years. If you even go back a little bit farther than that, 7 years, 10 years, most of these systems were not being used in any great capacity at all within the industry. It was a very, very niche markets that we tended to see unmanned aircraft utilized in, primarily things such as military applications or very, very specific scientific applications. The bar was pretty high in terms of cost and training requirements in order to be able to utilize these things. With the advent of commercial drone technology, really driven by the smartphone developments in terms of very small sensors, very capable small microprocessors, has allowed these things to, literally explode exponentially in terms of how many systems are currently out there. And just like we're seeing this in the unmanned aircraft industry, we'll expect to see this in all autonomous vehicles, as Sudhir mentioned, unmanned surface vehicles, subsurface vehicles, as well as ground vehicles. And so there are going to be a lot of different applications that we're going to see in the energy sector. We'll see lots of different unmanned vehicles being used for a number of different jobs. So we're still seeing this growth right now in terms of the number of licensed, what we call Part 107 pilots. That's the portion of the FAA Federal Aviation Regulations that allows you to fly drones within the national airspace. Now, as I mentioned, there are lots of different form factors for these: fixed wings, rotary wings, and even within those subcategories, so you see lots of different shapes and sizes of these systems, really dependent upon the type of application that you're looking for. All drones really have one thing in common. They have to have some kind of payload, and that payload is really what we're interested in. We don't really care about the drone or the unmanned aircraft itself. That's just a method to get the payload where we want it to be. Whatever type of system that is, whether it's a chemical sensor or a visible or infrared camera, what we're interested in is being able to get that payload from point A to point B, have it take its measurements and get that data back. So we tend to think about these really as data delivery systems. So that way you're increasing your capability to get the data that you need. And whenever I talk about drones, I always like to go back to the hype cycle. And for those of you not familiar with this, this is used quite a bit in Silicon Valley to describe the life cycle of new technology and how that technology is introduced into the industry. We see a new idea, a new system, a new widget developed, and pretty quickly, people think it's going to be the greatest thing since sliced bread. Then reality sets in, and we go from the peak of inflated expectations all the way down into the valley of death, this trough of disillusionment where we're never going to get this to work. This will never be useful in our particular industry. Slowly, bit by bit, as you're getting the feedback from those early adopters and those users in the industry, the developers are able to improve those systems to where finally we get to this plateau of productivity and these systems are finally useful. I always go back to, things like the smartphone, because we're all very familiar with those. And we can remember, the issues that we ran into with smartphones early, in their lifetime where, hey, even the iPhone had trouble, making simple phone calls. And, when Siri and voice recognition started to be developed, all the issues that you had with that. But it's just, continuous feedback cycle that you're able to finally get things working well enough that you can utilize them in the industry. Now, these are tracked. The hype cycle just isn't a hypothetical construct. It's actually used in the industry to track all different types of new technology, including both unmanned ground vehicles and unmanned aircraft systems. Notice both of them have passed that peak, and now we're somewhere within that valley of death, that trough of disillusionment. And one of the things that we see ourselves doing, particularly at the Unmanned Systems Research Institute at OSU, is trying to build a bridge. So that way we can cross that trough as quickly as possible and get over to that plateau of productivity. But one of the things that we notice, to get there, to make these systems really practical and useful, is new technology has to be implemented, developed, and tested to demonstrate that it really is robust to be able to get us to that point. Now, going back to that timeline where we mentioned, that drones have only been around in the industry for about 5 years or so. It wasn't until 2016 that the FAA even had regulations in place to allow you to use drones in commercial applications. Prior to that, you could really only use them either as a hobbyist or as a government entity, as a research organization, for example. So it wasn't until 4 years ago that the FAA put the Part 107 regulations into place. Now, as part of that, they recognized that the limitations are pretty onerous. 400 feet may sound like a lot, but when you're trying to do surveys and observations, it doesn't give you a lot of leeway. There are also requirements in terms of being able to operate a drone, a single drone, and maintain visual line of sight with it. So that also limitates its usefulness in terms of how far away you can fly. And then also how many vehicles you can operate at one time. And so they recognized that there were going to be new technological developments that would allow these new modalities to be used. And so they developed a system of waivers and exemptions that allow people to come in and apply to those. The ones I'll be primarily talking about are the one-to-many or the swarming, and what we call BV loss or beyond visual line of sight. Now, going back to our UAS airspace operations, under the Part 107 rules, we're required to fly the vehicle in Class G airspace up to about 400 feet. And it's not for the safety of the drone, and it's not for the safety of the drone pilot. It's really for the safety of other aircraft in the area, particularly manned aircraft, because there is not a requirement currently that requires manned aircraft to be able to see drones in all different applications. So there has to be a way to deconflict the two vehicles in what we call non-cooperative airspace. So that way the manned aircraft can be flying over, and then you can be operating your drone at some safe distance below that. That's what we want to avoid, is people flying drones up too high, and then that becoming a safety hazard for that manned aircraft. So this is our current paradigm that we have right now, that we're flying the vehicles, whether they're rotary wing or fixed wing vehicles, we're flying them out, we're operating them, and here's our really fancy animation that we have that shows that the vehicle is flying over and doing its job, inspecting whatever we want to inspect, or searching for new sources of energy. And the requirements are that we maintain visual line of sight, that the operator has to be able to see that drone. And it's not really a matter, again, from the FAA's perspective, that they care that you can see the drone. What they care about is that the pilot has the ability to see other aircraft that may incur upon that airspace. So that way, if you see that there's another vehicle flying in, that you can land that drone very, very quickly. So maintaining line of sight is the most important piece of that. So that takes us then to really the next useful piece that we want to be able to implement, which is beyond visual line of sight. So now that allows us to fly the vehicle beyond the visual capability for the pilot to be able to see it. And it could be just a matter of distance. You're flying really far away, so you can no longer see it just because it's very small. You're flying, over a building, over a mountain, whatever it may be. Now, there are a lot of pieces in there that we have to be able to fix to make sure that things are working, primarily communication, since it's a radio communication between the control system that the pilot has and the drone. You know, we have to make sure that that communication link is not only robust, but also secure, so your data is not being stolen. And, you know, there are ways that you can use that over 4G or 5G networks, or even satellite links to be able to do that. Now, to make that requirement happen, so we've been involved in a lot of beyond visual line of sight development and testing. We have a beyond visual line of sight corridor at our flight field, which allows us to do limited testing. It's only, you know, it's less than 20 miles long, but that's long enough for us to do the demonstration of the technologies that allow the vehicles to be able to navigate safely within the airspace. And essentially what we have to do is have the computer on board the aircraft be able to see the environment around it. And by see, that may be using visual systems such as cameras, or maybe using things such as radars that allow it to map the surrounding. And then, just like a real pilot would, or a manned pilot would in a manned aircraft, if it sees that there's another aircraft in the area, be able to develop a maneuver to properly avoid that aircraft. Now, the next piece of this that we're working on is full autonomy. And when I say we of course mean the entire industry. This allows you then to take the pilot essentially out of that loop of having to do minute-to-minute navigation of the aircraft. So now you can be in your base of operations. Again, all you care about is the data. You push a button, the vehicle goes out, it flies its mission, and it's able to then maintain some safe separation between it and other potential aircraft within the area. So once we have that piece, it allows us to do the next stage, which is autonomous swarms. Because now that the aircraft can only see other aircraft in the area and they're able to operate autonomously, then you can easily, instead of just operating one aircraft from one pilot, you can have one pilot operate many aircraft. And that allows you to do lots of things. And so there's an example here in the video off to the left. You'll see two fixed wing aircraft flying a maneuver. You'll see that they turn in coordination with one another. And what one aircraft is doing in this case is leading. It has a flight path that it's following, and then the other aircraft is following behind it, making sure that it maintains a safe distance and separation. Then you can start to do this with rotary wing vehicles and operate them in large swarms, so that way they can start to behave in a coordinated fashion, going out, and rather than taking all day to get your data set, for example, you now have the capability to go through and get your data much more quickly by using singular sets of vehicles. Now, the final piece for this is to get what we call get to the point where we have an unmanned traffic management capability. And now this requires a lot more coordination with really communication systems and the capability for vehicles to be able to not only navigate and plan their path, but also coordinate with other vehicles in the area by letting all the other aircraft and potential vehicles know what their plans are. So this is where I'm flying right now, and this is where I plan to be. Are there going to be other obstacles if I'm going to be 5 miles down the road 5 minutes from now that I have to worry about? So you can think about this really as smart traffic and smart planning, mapping everything out with literally the cloud. So you send your flight plan, and then you're automatically approved by an autonomous air traffic control system that says that you have now the right of way to go through the process and flying through that area. And so this is the piece that the FAA is working on right now, really segmenting different ways that drone operators will be able to remotely identify their aircraft, so you know what the aircraft is doing, and then having that aircraft file a flight plan autonomously, and then have that system approved, again, through a computer-controlled flight path management system. Now, what this will finally let us get to is implement other pieces of technology which are in development now, but aren't really useful until we have these beyond visual line of sight and unmanned traffic management capabilities in place, such as flying really long endurance electric aircraft. So all the benefits of flying electric aircraft system, but instead of the really low energy density batteries that we're limited to, using hydrocarbon energy to be able to tap in to that chemical energy potential to give us much better improvement in efficiency, and then allowing us to then do long range inspection, particularly of things such as pipelines, power lines, and really starting to use these things for their full capability for things such as exploration. So I'll end here with a piece we've been working with first GE and then Baker Hughes on their methane inspection system. And this is just their ad that they put together to really kind of provide this capability where you're able to take the systems out, put sensors on board that allow you to see things that you normally can't see with the naked eye, such as methane leaks, and then take that information and send that back to the operators to provide them with some actionable data that they can utilize to have a better handle on what's going on within their particular operations. So that's the end of my talk. I have my contact info here. If you have any questions about anything, I'd be happy to answer them. Just drop me an email. So thanks for your time.
Oh, that's great.
Over to you, Susan.
Yeah, and I just have one quick question, because I know that we'll have more time for more questions. I'm sure a lot of people are wondering. So on the sensor, for example, if it's a FLIR infrared, do you use, how do you detect the leaks or spills? Do you use vegetation and hyperspectral or what? Or
well, you can use all of the above, right?
Okay.
So particularly with the imaging sensors, primarily you're looking at certain wavelengths, and whether those wavelengths are absorbing things from that particular element that you're looking at or molecule, or whether they're emitting, that you can use those and that sensor really to its best advantage. So it really just depends upon the details. So it's a mixture, kind of all the above. The non-dispersive infrared sensor, for example, that's being used here, and I think there's some examples of this that are provided, within later portions of this video. Again, really, it's looking at blocked portions of the wavelength where methane doesn't allow light to transmit. So you can use a particular wavelength that's being emitted from the sensor, and based upon how much of that wavelength is being returned, how much of the energy is being returned, you can determine what the concentration of methane is. But that's just one example. And
I guess also you still can use vegetation as a proxy.
Correct, yes.
Yeah, that's interesting. I mean, it's a little bit, it's not an immediate detection of but it could be good for saltwater spills or something like that.
Yeah, doing things, using things such as the NDVI system that you use to actually detect crop health. And you can use that as that proxy to be able to determine, what other sources are, within the particular environment that you're looking at.
It's really interesting, especially when you consider the use for precision agriculture. And was it Blue River that when it was bought out by John Deere started using that quite a bit?
Yeah, and again, we're going to see a marriage of this through a number of different industries. It's precision agriculture is really focused on ground vehicles right now, but you're just starting to see a much greater use of aerial systems in a precision agriculture.
It's just so interesting because you save so much in terms water and fertilizer and all that by doing the precision. Anyway, thank you very much. This is so great. Really appreciate it.
Oh, you're welcome.
So our next presenter is Bob Dahlstrom, and I'm really excited that he's here. He first got involved with AAPG's UPitch 2 years ago in Denver, no, in Houston. And it was really great because at that point, Apellix was at a more of a startup stage. And now you're at like probably level 4 or 5 in terms of, at any rate, it's like really, really glad that you're here and really interested in how you've evolved.
Thank you. Thank you. Well, we're getting there. It wasn't that long ago, you're correct, that we were a startup. I guess we're sort of an emerging technology company at this point. But going back to Sudhir's comment about silos and the tool that you need maybe in your neighbor's toolbox, that's what's great about these presentations that you're putting together. That's what's great about even something like a robot and a drone and putting those together. So if you notice on this slide, what you see is a drone, it's up there flying, but what else do you see? A robotic arm on there, and at the end of that arm is a hand that's physically making contact with the surface. So the hand is called an end effector. So what we've done at Apellix is we've taken and married the two together and created what we call an aerial robotic system. People also call drones aerial robotic systems, but in our case, we've actually added a robotic arm to the drone to enable it to do work when it's in physical contact with structures or close to structures. So let me just pop a little bit. Oh, also wanted to mention too, Jamey's talk about the hype cycle slide. We have that exact same graphic over our printer at our office. Because one of the things we have found as a new technology company, everybody looks for the edge use cases. They're like, oh, okay, well, if you're developing a spray painting drone, then you can surely spray paint the Golden Gate Bridge. Well, the answer is no. You have to crawl and then walk and then run. So you've got to do something like a flat vertical surface, like a warehouse with wall with no doors and no windows first. And then over time you iterate and get more complex. So we have to keep managing expectations and pulling people back to maybe in the future we can do that, but right now we can only do this. So a little history about the company. Founded in 2014. We focus on the software control of drones, and just like the previous presenter mentioned, we really don't care about the drone. It's just a mechanism to get us at elevation where we can do work. You know, if we could buy one off the shelf that did what we needed to, we would be happy to do that. We can't, unfortunately. We've modified the drone so much that we have to build our own. And in part because what we're doing is very dangerous, because in aviation history, aircraft have never flown close to or come in contact with structures. It's just dangerous, and it's not something we want to do with a human pilot. The three things a drone needs to fly is it needs to know its position. Where is it in the world? Well, yeah, satellite. If you're behind the ship of a hull, the hull of a ship, you can't see the satellite, so you can't rely on that data. The second thing it needs to know is which direction is it pointing, and it uses magnetic compass. Well, again, big piece of metal says, hey, guess what? I'm north. So the compass is wrong. And then the third thing, just like aircraft, it needs how high off the ground is it? Uses barometric pressure. Well, again, next to a wall, barometric pressure is wrong, those readings. So that's why a lot of people don't fly close to structures, because their drones crash. They were never intended to do that. And we've spent a lot of time in developing the software to enable the onboard sensor array to ignore the data that's coming in for the typical flight control and to fly off of the data for the localization instead. So we have 4 patents pending, or I'm sorry, 4 patents awarded at this point. 2 are pending. We won the National Association of Corrosion Engineer Innovation of the Year Award in 2017 for the drone that you saw in this picture here that physically flies up to a structure and touches it to make contact-based measurements. Started with myself, my co-founder, and a good friend from a previous company I had, my CTO, Paul Hunkin. But one of the things we do too is with these systems, we're able to move workers from elevation and put them, stop them from doing the dull, the dirty, the dangerous work, put them to a higher and better use of their talents, where they're making the judgment calls based on the data that they're collecting. For example, we're collecting ultrasonic thickness testing. That's what the UT is here. That's for the wall thickness of steel on a ship's hull or ground storage tank or an elevated water tower. Currently, that's a handheld transducer that's held by a person up to the structure to take that measurement. Well, to get that person at elevation to do that job requires a lift or a crane or scaffolding or potentially rappelling down with ropes. And it's time consuming. To do, for example, an API 653 inspection of an above ground storage tank may take 2 engineers a day and a lift to get 40 measurements. With the system that we've created, we're getting 120 measurements an hour. So it's also enabling us to gather more data. And this is what I want people to keep in mind if they're thinking about starting businesses themselves, or how to use drones or robotics to tackle problems within the industry, is you need to look at something that improves the current process. Something that maybe lowers cost or does a better job. Like in our case, we're able to collect more data than a person could collect. And then also, safety. Safety is a big issue. So having something that's a safer process is very, very good. So this is an example of what the pilot sees when they're flying it. And this is testing. This is a green liquor tank at a pulp and paper mill. And you can see the corrosion there, and you can see the end effector from the drone. This is the user interface that the pilot sees. So the pilot flies it up, clicks the button to engage the software, and at that point the software goes in, makes contact, takes a reading, and then that's what you see at the bottom there, the reading the thickness of the steel from that measurement device that's on the drone. The corrosion engineer that's with the drone pilot also has their own user interface, and they're able to see in real time the data that's coming off the drone system. In this case, this user interface is for dry film thickness, which is coating thickness or the paint thickness. So this is measuring the thickness of the paint. And this allows the corrosion engineer, in the past, they would have these handheld devices, they would physically touch to a structure. Sometimes they then whip out their notepad and write down notes. This allows the corrosion engineer to gather a lot more data for the corrosion monitoring location, set the parameters for what is considered within variance or out of variance. That's where you see the red and the green for the different readings, and also just gather more data, because a drone is nothing but a computer, and a computer is a data gathering machine. So we collect a lot more information than having a person do the job, just like you would with the, for agriculture with the thermal cameras that can see human eye can't. So we have pilot projects that we're working on now with various companies. We have, I'm happy to announce that as of today, we have our first flight of one of our new products coming out, which is a soft wall drone. That's a chemical washing system that it's high volume, low pressure. So it's about 1200 PSI. It's about, I think, 8 to 10 gallons per minute. And this is designed for use in elevated water towers, 150-foot water towers that have mold that builds up on the outside of them. So the system had its first test flight today and flew well, but also we found some things that need to be changed. So we'll be fixing those and moving that on. But so we have this, and the reason I bring this up is we have this objective as a company. We play in the corrosion space, and that's why we're interested in AAPG and oil and gas. Is we want to take an asset when it's new, an offshore oil rig or whatever it might be able to coat it with or paint it with our drones. So we're under development for a spray painting drone with Akzo Nobel International Paints, which is one of the largest paint companies in the world. we're about 9 months into a 24-month development cycle with that, making some very, very good progress. But we want to be able to take a new asset, code it when it's new, clean it as it needs cleaning, measure it over time, maybe blast some paint off when it needs to be repainted in certain areas, repaint those areas, and when the whole thing needs repaint, repaint the entire. So that's part of our objective as a company, is the whole life cycle asset management. And we feel that we've been lucky enough to come up with a platform that is able to change the world. Again, if we're able to remove people from elevation, have them focused on more their higher use of their skills, that's a good thing. If we're able to apply coatings without a person having to be there, that's a good thing. If we're able to gather data, and this may be the most important of all, is that data that we're able to gather that we can then feed into the digital twin that can then help make better decisions on the underlying performance of that asset or the life cycle of that. And this now, the standards, for example, for SSPC PA2 for dry film thickness, or the standards for API 653 for ultrasonic thickness testing of wall thickness, were written for people like those you see in this picture on these structures and taking these measurements. And again, if it takes all day to get 20 measurements versus a drone that's getting 800 or 1,000 measurements in a day, you can change that statistical sampling and actually end up with a better understanding of the condition of that underlying asset. And so we're starting to see some of that happen, and that's where the value of the data starts coming in. Then you're able to also, the machine learning, artificial intelligence. You may over time realize that when you're testing pipes like this one here, that on the north side, things grow that need to be scraped off. And so you may have your drone do more inspections on the north side of the pipe than on the south side of the pipe, which stays cleaner. So there are different things that can help with the data that you're able to gather with these systems. And that's it.
That's fantastic. There's so many questions from the audience too. This is great. And I just want to let the audience know that we will be sending, I will also send a transcript of the questions and answers, so you can go through them at your convenience, because we will try to go work through them. Let me.
Can I ask a question first?
Sure.
I had a curiosity about the drones. How far away is programming to put those things on autopilot rather than having an operator to manipulate them?
Yeah, so right now we're very close to the structures. So we call it the gate or the window when we disengage the autopilot and engage the onboard to fly, and that's at about 2 to 3 meters.
Okay.
So the pilot manually would fly up to a location within 2 or 3 meters, point the drone in the right direction, and then at that point they push the button on the tablet that says engage software, go in and take a reading.
Another question too. You indicated using the drones for maybe blasting or prepping pipes, or maybe water towers for painting and going through that process. What about these up in the sky communication towers that scares me to death to see some guy climbing up there? Is there the capability in the future for the drones maybe to go change some component of a satellite or an antenna to keep a person from having to climb up there?
Potentially, but that's going to be long term. So right now with the precision flight control, we are able to make physical contact with the structure for most of the time until a valid reading is received, and then we back off because we stay in physical contact longer than we have to. So right now, maybe 5 to 6 seconds is the longest we'll stay in contact. But to actually physically have a drone that has torque that would like unscrew something or screw something on is beyond our current capabilities. It's something that we anticipate in the future, and it's something we have in some of our patents, but it's not anything we're developing now. Again, we're using the whole crawl, walk, run mentality, and we're also trying to listen to industry and do pilot projects with industry, find out what's working, what's not working, find out from industry what's the next thing that we can do that will add the greatest value. And that's one of the things I wanted to point out too. When you were talking about the lean startup, or I'm sorry, talk about the hype cycle slide, and you've got the valley of death, you know, the inflated expectations valley of death. And then finally you get up to that plateau of productivity, production. Using the lean startup model that's available to people now can really compress that to where you get to that plateau of productivity a lot faster. And that, you know, this is my second company. My first company was an internet security software company, and I started that, you know, last century in 1999. So it's really interesting. Back then, you went out, you did a business plan, you pitched it, you got money, you built your product, and then you failed, and then you had to pivot. Well, now the lean startup kind of builds that opposite, puts that on its head. You go out, you build your minimum viable product, you test it with your customer, you figure out where the value creation is, and you get the customer feedback. Then you go and get, you know, funding to develop that and take it into the market. So, you know, I would encourage anybody who's looking at new revenue streams or starting a business of your own to take a look at the lean startup model. It's very good framework to use for developing technology.
You know, that's true. We see that a lot, and it's it at least gives a proof of concept up front. So Sudhir, I wanted to ask you, because I remember a presentation that you made at OTC a couple of years ago about underwater, basically autonomous vehicles, and how they were able to do repairs. You want to talk about those?
I can talk just a little bit, because that was the time when it was kind of going into a pilot phase, and it was based on some work which was done. In fact, I think there is still a nice video available still on YouTube, wherein it shows one of the Saab CI in Sabertooth underwater vehicle, which went out and for the first time ever in the NASA tank between two astronauts, you know, zero gravity training times which are going on. It went there, and for the first time ever opened and closed an underwater valve. Just to mention what Bob had mentioned, a lot of work I think has happened, and I briefly touched to it by those three-letter you know, oil and gas acronyms called IMR, inspection, maintenance, and repair. A lot of inspection is happening. You are going there and finding whether things are okay or not. But the issue is a lot of times people back off because, fine, I found out something is wrong. What do I do next? Because next you have to move into maintenance, and then even bigger thing, I now know what is wrong. I know it's need to be fixed. I need to come back onto repair. So a proof of concept, to answer your question, so the proof of concept was done, and then it was left for it to then go ahead and put into commercialization until, you know, we were hit with the current environment and things like that. Yeah.
My understanding, in the maritime industry, there are some ROVs underwater that do work on ships' hulls. So they will scrape the hull, they will clean the hull, they will weld, and there are some that even paint underwater. But again, ROVs, the underwater vehicles, have been around for 50 or 60 years.
Yes.
They've been around a lot longer than, you know, aerial robotic systems are the newest. Ground-based robots have also been around for a while. Also, with water, you do have some torque to help maneuvering of a system, but you also have the problems of current. Similarly, with air, you have less because air is amorphous, but you do have more, and you also have problems with. So it's hard to bite the air to keep the aircraft up. It's even harder to bite that air and have the aircraft do a maneuver. So it's just different physics, different technologies, different development cycles. But eventually, I do foresee drones being able to do work at elevation that will replace what humans
Yeah,
are currently doing.
those are good observations. And let's ask Jamey his thoughts on some of these. He's
Yeah.
had a lot of questions. And anyway, I'd like you to weigh in.
Just to complete that point, I agree with Bob had mentioned. The issue again comes with and I presume you asked more about deep water rather than just closer to the subsurface. And I think that's where the challenge still comes. A lot of technology is coming in, and maybe at one of the next sessions, it might be maybe nice to put together that part of the part of the area that we can look at. A nice theme there, Susan, is probably we seem to know more about space as compared to the fact that 70% of our Earth is covered by water, and how little we know, particularly in the deep water area. So a lot is known in inspection, but I think a long way has to go to be away from the time that we can get away from having divers going out and replacing them with the commercial autonomous diving equipment. Yeah.
That's true. Okay, so Jamey has lots of questions in front of him. So,
I was just going to pick up, Robert was talking about having vehicles operate at altitude, and there are a couple of interesting things that you can discuss about that. But I think one of the exciting ones, it's not petroleum geology related, but it is geology related, with Ingenuity, being launched by NASA last week. Which will be the first aircraft to fly on another planet about 9 months from now. And again, it's a very simple rotary wing drone. And all it's going to do is hop from one place to another place. But, it allows those robotic explorers that, we've been very commonly used to now, that these really complicated systems that are operated, millions of miles from home, that have 20-minute lag times between communication, that have to be very autonomous. And if you can do that on Mars, eventually you'll be able to do that at a reasonable cost on Earth, as those technologies that are being developed kind of make their way back home. And I think it's kind of a really neat example. Things that are being tested right now, mostly in academic laboratories, are hybrid systems which can fly in the air, and then, using those same propulsion mechanisms, can go underwater. So completely hybrid. And so now you have a vehicle that is not only a subsurface vehicle, but also an unmanned aircraft. And so you'll have vehicles that will be able to do multiple roles and multiple missions.
Oh, that's really interesting. And there are a number of questions that have to do with imaging and the types of images and getting, making 3D images. And I think that you, if you don't mind talking a little bit about, say, point clouds and models and 3D models.
Oh, sure, yeah. And this is something that's being, used right now with UAS, and very commonly, you can purchase even something like a $1,000 off-the-shelf drone, in implementing software systems that allow you to combine all of your images, just simple visual images, using methods called photogrammetry or structure from motion, that allow you to generate essentially a three-dimensional CAD model or point cloud of all the data that allows you then to take that into a computer and do estimates such as, volume estimates. So if you have a pile of coal, for example, you can determine with really great accuracy, how much volume you actually have within that pile. And that's being used in a lot of different applications, just using visible images. Then once you start to marry that with infrared imaging and near infrared, to be able to determine more details about the things that the naked eye can't see. And then other active sensors such as LiDAR, which have much greater accuracy in order to be able to pull these things together now in real time. And this, I always talk about this as a data problem. This is big data. And so getting this information back where you might have gigabytes of images or terabytes of data from your LiDAR that you then have to start to deal with. So that becomes a whole different problem that you have to prepare for as you're getting the data off of these systems.
So in terms of the data storage, et cetera, where do you see the challenges of say, cloud-based systems that collect it and goes directly to the cloud versus collecting the data and keeping it on board?
Well, that's not necessarily my my expertise, but right now it really boils down to transmission.
Okay.
It's still a lot more effective to store something on some kind of physical media and then take that and transfer that directly to another computer than it is to transmit that data over Wi-Fi or over Ethernet, let alone something like a 5G or 4G network.
Mm-hmm.
And so that really becomes the bottleneck in terms of getting the massive amounts of data that you need to the computers to do all the processing. At the end of the day, all we care about is that result, that one image or that one number that's being spit back from the system. So that gives us actionable information that we can make decisions on.
That's really interesting. So we have so many questions. Let's see if we caught any. Somebody wanted to know about how to get started, like a beginner drone, around $500.
There are systems out there, even if you go to some place like Best Buy. They have systems within that range. I think generally what you'll find, with anything else, you get what you pay for. And so if you spend a little bit more money, kind of up into the around $1,000 or so, you'll find systems that are going to be much more reliable and capable. But you can still find some good things that you at least to get your feet wet, for several $100s.
Yeah,
Yeah, I agree. I found, what was it, about a year ago or so ago, DJI Mavic for about $500. The only thing I would encourage everybody to first thing, particularly after the two presentations that you had seen from Jamey and from Bob, please go ahead and register it, no matter how high you are going to go. Even if you are going to stay within your area, it's important to go ahead and register it, because the laws are changing on all of this stuff. As much as, in recent times, what taught us a lot was what could have been done were we at the stage of maturity as today, when Hurricane Harvey came through Texas, and the kind of information we could have gathered sending unmanned technology out there, which you hope not to lose, but if you did, not an issue. At the end of the day, anything you can do before you put humans in hazardous areas, let alone life being lost, going out trying to find out what's happening is so important. So I think it's been a rude awakening to everybody, and sometimes those kind of natural disasters drive us to push in the right direction to make sure you make a lot of these laws open so that you can react in time, particularly to natural disasters.
Yeah, we're using systems quite a lot in various natural disasters, post severe storm damage, after wildfires, structure fires. So, there are a lot of applications there, but there are also, hobbyists and consumers, that may not be completely aware of the laws and regulations, and think that they're not really doing any harm, so it's innocuous. But I think there was a Major League Baseball game. I think it was the Pirates that was delayed a couple of nights ago because someone flew a drone over the stadium. So they had to put the game on hold for a while. And of course, there was the issue last year with the drones shutting down air traffic in London.
Oh, right. And also privacy issues, I guess. Some of the privacy issues and what you can or cannot fly over in terms of national security, et cetera.
Yeah, I pasted a link for those that are wanting to get started for the FAA.
Oh,
That's a
thank
good
you.
resource to go to.
So I have a question for you, Bob. How many of your robotics, I mean, you talked about the dangerous conditions, et cetera, and I would imagine that you go through quite a few of them. How long do they live?
Yeah, at one point in the development of our systems, I used to tell the team, if you're not crashing, you're not iterating fast enough. We've been fortunate that we haven't had any crashes in quite a long time, but these are also new, and we don't know how they're going to operate long term. For example, we're finding the best motors we can source. And the mean time between failure, for example, may be 600 hours of flight. Well, that's for a drone with a camera that's flying up in the air, taking video. That's not for a drone that's next to a structure that is making 50 micro adjustments to the per second and doing, all these different slow flights.
You'll see a box.
Different type of technology.
One of the
I wonder when we have our first instance of somebody trying to shoot one down. I saw a news report, I think it was in Beverly Hills, some celebrity party, and the drone came in to be filming them, and they got all upset about that.
Well, that has already happened, so people have shot them down. So,
oh, yeah? Okay.
And been prosecuted. So I'd recommend not doing that.
The shooter gets prosecuted?
Yes.
Okay.
Yeah, the FAA treats any unmanned aircraft like any other aircraft.
Okay.
So they don't want you shooting at a manned aircraft or an unmanned aircraft.
All right. Where's the line drawn for private property?
Well, as far as the FAA is concerned, privacy is not their purview. Safety is.
Okay, gotcha.
So this goes back to Fourth Amendment rights and expectations for privacy. So and that's a big discussion in the community right now.
Yeah.
So there needs to be other laws enacted at some point in the future, but that's for another day.
Good topic. Okay, so another question is to come in that in terms of COVID-19. So are there any boosts to what are you seeing any changes either and this is to all three of you, that in terms of robotics or drones in response to our changing world of COVID-19?
For us at Apellix, unfortunately, there's been delays in pilot projects that we had set up due to travel and get personnel on site. So one example is we're scheduled to measure the thickness of a Navy destroyer and the thickness of the hull on one part, and then they were going to paint it, and then the thickness of the paint. But because it was a non-essential personnel, that was put on hold, and basically the ship sailed because they were done with it at dry dock. So our next opportunity would be the next ship that comes in October. But on the other front, because there are issues with getting personnel out in the field in certain instances, having robotic systems that require fewer people or people that can distance themselves has some advantage. So we've heard a little bit of interest from from infrastructure and energy and maritime about the robotic systems that do inspections, just because that's a way to still get the data that they need without having to put people out there to do it, or fewer people to do it. So it's been very mixed for us.
So, okay, go ahead, Sudhir.
Sorry, Bob didn't want to interrupt you.
No, I think you can.
I'm done. Yeah.
Okay. Yeah. No. Yeah. No. It's interesting. I don't have the full details of this one, but I do know that a representative at the TCC from the Baylor College of Medicine is working on an important project by which a lot of the samples, particularly in the Texas Medical Center, are will be transferred between the various entities rather than having humans to take them across, etc. And the fact that you have to have humans go through areas wherein they could be subject to virus and things like that, using the drone technology to transfer between various centers within that one area. Yeah. Now, other than that, we hear quite a bit about remote areas in West Africa and other places wherein there are real stories of the drones being used to transfer across regions which are strong marshlands and areas where transportation can't be done. Airplanes are not easy to get, etc. And these are easy ways to move equipment across. And that is happening today on a pilot case basis, about to jump up when the commercial need goes up. So certainly those are two key places that I know are the hotspots wherein this technology is certainly going to be extremely useful, not only through the pandemic, understanding that some of this is with us for a while. Yeah.
Oh, interesting. Yeah, that's good. Jamey, did you have some?
Yeah, I was just going to add to Sudhir's comment. If you look up the company called Zipline UAS, and that's I think the one that you're referring to, they've I think they're now in the tens of thousands of medical deliveries in the Rwanda area. Where they're doing multiple deliveries per day, where it'd be very, very difficult to deliver medical supplies to the regions that they're flying over. Now, you say, well, how come they can do that, but we can't do that here? Well, there's very little other infrastructure that, if a vehicle crashes, it's not going to hit another aircraft. It's, it's going to land in the unoccupied or unpopulated jungle rather than crashing into an urban area. But it's it's not only great utility, but it's also pushing the technology forward. So there have been limited pilot studies at, the FAA has several test sites, including one in southeastern Oklahoma, where, you have a safe area that allows you to test these technologies within the U.S. national airspace. So it's just a matter of time, we're making sure that these systems are very, very robust and very safe. And the COVID pandemic, has brought around a number of interesting opportunities. The Navy, for example, is trying to figure out how, you reduce contact and you still have the capability to deliver supplies from ship to ship, whether that's using surface vehicles or aerial vehicles, to be able to do these autonomous deliveries.
That's super interesting. And I guess also surveillance, instead of using a person to, or checkpoints and things, for counting people, you could use drones.
That's right. Yeah. I mean, again, this is where I think these kind of unmanned systems, no matter which spectrum you are looking at, if we made this as a point that in hazardous areas, having a human out there should be the final resort when everything else doesn't work. If we made that as a mission and a motto, suddenly you start to work through, of course, at no cost jeopardizing or compromising safety, right? And that's the bit which I think Jamey and Bob was also kind of emphasizing. Provided those things are taken care of, you know, this kind of pandemic, etc., are really going to accelerate the adoption of these kind of technologies. I've seen more work happen in the last 3 or 4 months related to unmanned aerial systems in the healthcare industry than ever before. Yeah. So
that's interesting. So one more question. Henry Lee asks, just out of curiosity, are you using machine vision with convolutional neural networks to build and train your AI model? Not quite sure who that's for, but.
Yeah, I'm not sure if that's for me or for Bob. We do use machine learning quite a bit. Just one recent example, we have a project where we're using UAVs to identify regions in rivers where endangered fish, migrate from one area to another. And so we're looking for regions of connectivity, so that way you can map out those regions. And so we're using machine learning with neural networks to be able to identify different sections, which again is very easy for a human to look at a picture and say, yeah, I see that this part of the river is connected to this part of the river, but it becomes much more difficult for a computer to do that autonomously. And when you're, trying to do this for thousands of pictures, if you can develop that artificial or neural network to be able to do this through some kind of AI capability, then you're able to really increase your throughput of the amount of data that you're able to process.
That's interesting. So could you use it for getting a good sense of where to noodle? I'm kidding.
Yeah.
I'm just kidding. Anyway, interesting. So Bob, do you guys use AI?
Post-processing, we use some machine learning. I guess you could call part of it AI, but it is something that we're moving more into as we expand our services from, because we've been focusing on, precision flight and making contact with the surface and gathering data while in contact with the surface, because there are plenty of drones out there that do visual inspections from a distance. So now that we've got that nailed and locked down and working well, we are looking for those systems to integrate into that so that we can, do that photometography where you stitch the images together. We can do that 3D mapping and point cloud, and we can do that, that digital twin to allow our customers to have that insight into their asset. And part of that is once you have that data, you can then run it through machine learning. You can then apply artificial intelligence to it, where there are some companies we've spoken with, that can take the AI for spotting in the video or still pictures corrosion or corrosion issues that are oftentimes not noticeable by the human eye.
Interesting. So Paul Genovese talks about a company that's developed drone technology to use thermal imagery to take temperature of pedestrians and measure social distancing. Oh, I remember seeing things like that. Interesting.
Yeah, they're great. Drones are a great tool and a great platform. With the pandemic, I've heard them that they use them for spraying to decontaminate. They use them for loudspeakers on them to tell people you're too close, you need to distance yourself. All sorts of things. But drones are just these amazing tools with all sorts of uses that are just phenomenal. And I just love all the crazy imaginative things people come up with. And Jamey, you probably know this, there's something called the snot bot, right? So there's a drone that when a whale comes to the surface and blows out water up into the air, the drone flies through that and it has sponges on it. It collects that mucus in that water, and then the scientists analyze it to get an insight into the health of that whale.
Yeah, we're currently working on a similar system for dolphins right now.
Oh, nice.
So, yeah, and it was very interesting how they used that. They just took an off-the-shelf drone, and with a whale being so large and their blow just taking up so much volume, it's very easy for them to do. But we're actually using machine vision to be able to train drones to identify dolphin pods, and the dolphins come up and their blow is they're much more narrow, and it exhales very quickly and it disperses very rapidly. So it's almost impossible to do that, but we hope to be able to train a more adaptable snot bob to be able to do that with the dolphins. And you say, well, why would you want to do this? And I said, well, I'm not a biologist, but the marine biologists look for cortisol levels, just like you do with a person. And then from those cortisol levels, they can determine the stress levels of the marine mammals.
And somebody had asked a question earlier privately, question and answer about software, and they're a Python programmer. And one of the beautiful things about drones is, and my Twitter handle is Mr. Drones or Software, because I call drones software. Because to me, a drone's a flying computer. If you're a computer, you're software. You can take a drone, and if you've never flown one, learn how to fly one. And eventually, with enough time and enough effort, you can do a barrel with it. You can make it flip. So I'm talking about a quadcopter with like four motors. You can actually flip that drone. Well, that literally takes 100 or more hours of flight time to be able to do that well. Guess what? A lot of drones now come with a button. It has software. You push that button, it does a barrel roll. Every single time you push that button, it executes it exactly the same. So software is what makes these things so amazing, and is what makes these drones able to do all the things that they can do. So I love to see applications of software added to the robotic platform that drones provide. And robots as well, drones and robots.
Super cool. Well, it looks like we're pretty much out of time. So I wanted to thank our presenters. So Sudhir and Jamey and Bob, really appreciate it. And we'll, when I send out the recording, I'll make sure to put your LinkedIn contact information so people can get in touch with you. And I want to thank you, Larry, also. And I want to take a moment to have a few little announcements. First of all, I want to thank Mark Hemzat for being here and for participating and helping with UPitch. Also, Julia LeMaster is here. I want to thank her. She's our Director of Publicity. Thank you for all that you're doing. Also want to just mention that we do have an internship/research assistant program. So email me if you're interested in finding out more and getting assigned to a startup to help out. And also we have, speaking of pods, but these are not whale pods, there have been learning pods that are coming together for STEM topics, and would like to know if any of you would be interested in volunteering to be part of it. In this case, maybe robotics or drone pod, learning pod to for your local school or learning pods that are assisting during this COVID-19 time to help people. So want to thank everybody.
Susan?
Yes?
Yeah, there was a question earlier. Sometimes a picture is better than 1,000 words. There was a question, I think, which had said, where can you make a start? So I ran down and brought it. I still have the box.
Good for you. Thank you.
This is one of the ones that people can go and buy, like they said, from Best Buy or somewhere else. Yeah.
Yeah, and so much of the software comes with it. That's like, I mean, good starter software. That's great.
That's right. Yeah.
Yeah, that's good. Well, thank you. So anyway, Larry, would you like to say a few final words, and then we'll.
Well, very brief. The presentations tonight were excellent, and the robotics and the drone future is very exciting. I mean, if we look forward a year or 2 years and come back to discuss this again, it'll be amazing the things that we're discussing at that time. The future is just beyond comprehension.
I totally agree. So anyway, we have a lot of things to think about. Want to thank everyone. You'll be receiving an email from me in a few days that has a link to the recording and also show notes with contact information for each of our speakers. And also just be in touch with me if you have any questions at all. So thank you.
Thank you.
Thank you, Susan.
Thank you.
Thank you.
Thank you.